I am Joyce Campbell,
And I'm Kanayda Walmsley.
and we both learned this subject of chemistry to a C level, which isn't that great, but we tried our hardest. And there's lots more concepts than the ones that we're presenting, but these are the ones that stood out the most due to very excessive teaching by Mr. Rasmussen. And I think no, just the first one. Thank you. Okay, so chemistry is split up into 5 studies, and it is used for oh my gosh, I'm so scared.
That's awesome.
So, in the first chapter, we went over the fact that chemistry goes worldwide. Why is it doing that? Okay. And how, in order to think like a scientist, you have to work together, problem solve, and do all of that chemistry stuff. And analyzing, calculating, and evaluating is the key to problem solving in chemistry.
In Chapter 2, Matter or Change, we learned that matter makes up everything. Mixtures can be heterogeneous or homogeneous. Elements and compounds, the composition is fixed and the material is substance. If it varies, it is a mixture. Chemical reactions, during a chemical change, the composition of matter always changes.
In Chapter 3, it was about scientific measurements, defining the atom, conversion problems, and density. The entire International System of Units is right here. We couldn't put the one that was like a UL, like a Latin U, because I couldn't do that with the keyboard, but it talks about what they originally thought the atom was, who came up with the ideas, and it talks about doing conversion problems very simply, like we all learned. And density always depends on the composition of a substance, therefore you can't find density unless you know that.
Chapter 4, the atomic structure, we learned that Democritus originally came up with the ideas, but Dalton formed it into a scientific theory. Structure of the nuclear atom, we learned the 3 types of subatomic particles are electrons, protons, and neutrons. Distinguishing among atoms, each element is different due to different numbers of atoms.
In Chapter 5, we learned about the electrons in atoms and the original models of it and how it progressed over the years, that whole diagram that we got to look at and redraw. We learned about the electron arrangement and how it's not actually the way that you originally thought it was, but it's a cloud around the nucleus. And it talks about also the physics and quantum mechanical model, which was honestly my favorite unit about this whole entire semester because I really love quantum mechanics.
In Chapter 6, the periodic table, of course we learned about the periodic table, but we also learned chemists use the properties to sort elements. The elements can be sorted into noble gases, representative elements, transition metals, intertransition metals based on electron configuration. And we also learned the periodic table shows trends between them.
In Chapter 7, we learned about ionic and metallic bonding. We learned that ions are formed. That's not. Okay, we learned that valence electrons and representative elements. Sorry, mine went blank. Okay. Atoms lose and keep valence electrons depending on their electronegativity, and they try to stay as far away from each other as possible. And bonding in metals is okay.
Chapter 8, covalent bonding, we learned about molecular compounds and how they have relatively low melting points and boiling points. The nature of covalent bonding, electron sharing is to achieve the configuration of noble gases. Bonding theories, the Vesper theory, valence electrons stay as far away from each other as possible. Polar bonds of molecules, more electronegativity, it attracts electrons better.
Chemical names and formulas. This was an extremely long and difficult chapter because when we were learning it, it gave us all of the the groups and the electron configurations helped us to name them and to make the equations from them. And using formulas was like easy, but then when we had to like transfer it over into the actual naming of them, like from back and forth, it was kind of more difficult, but it made us understand it better. And when we were, okay, so the laws of governing formulas and names, the ways that compounds formed, are summed into two laws: the laws of definite proportions and the law of multiple proportions. It was really a hard concept for me to like wrap my mind around at first, but then it got much better as we went along.
Chapter 10, chemical quantities. We learned a mole is a measurement of matter. 3 ways for measuring the amount of a substance are to count mass and volume. Mole mass and mole volume relationships. The molar mass of an element or compound is the conversion factor for converting between the mass and the number of moles in the substance. And percent composition chemical formulas to determine the percent by mass of any element in given compound is divide the elements by mass of the compound and multiply by 100%.
Chemical reactions. Word equations were the names of the reactants, and honestly we just learned how to put them together, and it's all separated like in between the reactants and the products was a arrow, and then you would put plus signs to separate the different chemicals and elements that were involved. And one more thing that I forgot. Okay, you can always predict the formation of a precipitate by using the general rule of solubility in ionic compounds.
Chapter 12, stoichiometry. Conversion factors and mole ratios. Mole ratios are used to convert between moles of the reactant, moles of the product, between moles of reactants and moles of products. And a typical stoichiometric problem, a given quantity is first converted to moles, then the mole ratio to the balance equation is used to calculate the moles of a wanted substance. Finally, the moles are converted to any other unit of measurement related to the unit mole. And then we have some examples.
Yay!